Hi, and welcome back to another session of our Summer for Success series. Today we have a very special guest speaker from the computer science program. We have Dr. Farahani, who's been teaching at NU for about 18 years. Prior to that, he taught at Fort Hays State University in Kansas, and his terminal degree is in applied mathematical science with a master's in computer science, both received from the University of Rhode Island. Currently, he's the lead faculty for the undergraduate computer science program here at National University, and his interests are in parallel computing, algorithm design, and optimization. Thank you, Dr. Farahani. Welcome.
You're welcome. Hello, everybody. Thank you for inviting me to your webinar, and I'm grateful for the opportunity to present the undergraduate computer science program to your audience. This is a brief presentation of our computer science program at National University. I'm the lead faculty for the program. Myself and another faculty member, we basically oversee the computer science curriculum at National University. So let me start by some quick facts about our program here at National University. We first offered the program, undergraduate computer science, in 1984. So it is over 35 years that we've been offering this program. We started delivering the program online in 2006. So the whole program was offered online, completely online. We used eCollege course management system along with iLink voice over IP system. So that's another, what is it, something like 14 years that we've been present online. We received ABAT accreditation in 2016, and we are up for renewal in 2022. So these are some of the facts about the program, and I think I have some more to say. And yes, the faculty member, there are about 20 faculty members, full-time faculty members that are in the Department of Engineering and Computing at National University. Myself and my colleague, Dr. Gargari, we are in charge of curriculum in computer science. We basically have meeting with our industry advisors every year. And based on the feedback that we receive from our advisory board members, we propose changes to the program to keep it relevant, basically. But again, we are the two faculty members that are in charge of the program. My focus and concentration in parallel computing is in parallel computing and algorithm design, and Dr. Gargari is in computer vision and artificial intelligence, in case the students are interested in any of those topics to do further research in those areas. So let me now move on to program learning outcomes. Once you graduate, you get your degree in computer science, we would like students to have achieved these following learning outcomes. There are 6 of them. We would like students to be able to analyze a problem and propose different solutions for that particular problem, be able to evaluate those 2 or multiple solutions that they propose for the solution to the problem. We would like the students to be able to do design. It could be object-oriented design or hardware design, and implement that design so that it would satisfy certain requirements, given requirements by basically the request of the client. Those 2 outcomes, they're kind of technical outcomes, but also the learning outcomes focus on soft skills as well. We would like students to be able to communicate effectively, and that includes presentation, and that includes also writing reports as well. Many of our courses in the program require students to write report, do some research and write a report, as well as creating video presentation. So especially online students will end up doing video presentation of, for example, an algorithm that they have studied. So that basically helps them improve their communication skills, basically. Another 3 program learning outcomes. The next one is, just go to the next one. Yes, being ethical, knowing the ethical issues in computing and behaving ethically. In fact, we have a course in our curriculum that basically goes over computer ethics and ethical issues in computing. Another outcome is we would like students to be able to participate in teamwork and be able to contribute effectively in a team work environment, basically. And the last one is kind of I would say it includes pretty much all of these outcomes that I've listed, and that is basically knowing computer science theory and be able to apply it to software development. Eventually, we would like students to be able to develop tools and software to be used by clients, basically. So these are the 6 outcomes. So every course in the program basically tries to develop these skills in students. Now, what about the curriculum itself? What do we have for the program? Our program basically starts with 4 programming classes. The first 2 are C++. That's our primary, or I should say the starting language. And then we follow that up with Java programming, 2 classes in Java programming. And then that is followed by object-oriented design, CSC 300. So those 5 courses, really the focus is on programming and design. By design, I mean object-oriented design and software engineering. So, and we would like our students, once they are out of CSC 300, those who are interested, try to apply for internship, because we believe at that level they have gained enough skills in programming and development that they would be able to start working at an entry level as an internship, kind of a student internship type of a position. The next set of classes are somewhat the theoretical part of computer science, and they are somewhat tedious. A lot of mathematical skills are needed and are developed in those courses. But that said, basically forms the foundation of computer science, foundation of theoretical computer science in our curriculum. By the way, all of these courses that you see, that they are all required by ABET curriculum. So when the reviewers come and visit our program, they make sure that we have the contents that's listed there in our curriculum. CSE 350 is our computer science, our computer ethics course. If you recall, one of the outcomes of the program is knowing the ethical issues in computing. Then we have 340, 342. Those are hardware classes. Basically, at this stage, students are exposed to inside of computer, the digital circuits, the gates, the decoders, the multiplexers, a bit of electrical engineering type of a thing is in there. We also talk about assembly language, and which is a low-level programming language, and then that leads to computer architecture. So in CSE 340, we basically expose the students to circuitry, so that could help them with computer architecture. When they study computer architecture, the central processing unit and the memory system arrangement and the buses, they are able to understand what they are reading, basically. Then you have a collection of 400 level classes. And those 400 level classes at a national university, I believe, is unique because oftentimes the schools will pick and choose among those classes, but it is required in our program. So students will be exposed to operating system, database systems, networking, computer networking, and programming languages. And recently, we revised the program and added the information security, and that was a requirement from ABAT as well, because the organization wanted graduates of computer science to be exposed to security issues in computing as well. So we added ITM 470. So once the students go through all those classes, we have a couple of electives. If you see it right here, the electives. Also, those 2 electives have recently been revised. We had mobile app development, which is very popular among our students, but we felt mobile app development is great, but our students also need web app development as well. So this course was revised to include both mobile application development and web application development. And recently we have added the artificial intelligence, AI, and basically data science content in the program. Computer graphics is not offered as often unless the students ask for it. Computer graphics requires heavy mathematics. It requires heavy understanding of mathematics, and again, depending on whether some students are interested in that topic, we offer it basically for them. So it's very challenging in 1 month format to go through computer graphics. And the program will end with capstone project, CSE 480. That is a 3-month course. And in there, actually, student will work on a project. And hopefully the project is sponsored by a client. And they work from scratch. They actually gather requirements for their software development. They design the solution, they implement it, they test it, and then they basically demo it to the client. So it basically includes all phases of software development lifecycle. And in fact, I believe I have some samples of projects the students have worked on. So this is basically this is our the curriculum in computer science. It's extensive. I think it's about 25 or 26 courses altogether. I've also included some of the textbooks that we used in this curriculum, in this program. Most of our books are digital. If we can find a digital version of the textbooks that we use in the course, we use the digital version. And in fact, we use ZY books. You see 2 of them right here in about 3 or 4 of our classes. They are very engaging textbooks. They are digital, and they have participation activities. They have animation in the textbook, so the content really is engaging, and I think helps the students better understand the content. And in fact, I think I have a couple of samples of what you would see in those ZY books. For example, as I said, it has animations, it has participation activities, it presents the lecture in a very easy to read and nicely, students can nicely go through it, and it flows nicely, and read it easily. And then once they are done with the reading portion, then they are presented with a number of participation activities. Some of them are simulation, like this one, that they would start it and it goes through steps and simulate solution. And then another one is a collection of multiple choice questions related to the topic that they were reading. And then and these are not the type of the scores that would impact student final grade. It's just kind of self-learning. The textbook tries to teach students, for example, the answer to this particular question is incorrect, and gives hints give reason why the answer was incorrect, and so forth. Then the correct ones, again, they are indicated by some description as well. So very, very nice books, and we continue to use ZY books and other textbooks that engage students. As I said, there are here are a couple of projects, capstone projects that students were working on recently. One of them is, again, create a mobile app, which is basically a travel guide application. This is for the city of San Diego. They wrote a mobile application. This mobile application has geolocation technology, and based on the location of the user, the cell phone, the mobile device will start giving the user a tour of the environment there, perhaps historic sites in there, and the history of the neighborhood, type of a thing. And then this is another project that was done. This one I believe was both mobile and web application, and it basically compared gas-powered vehicle with electric vehicle, and 2 compatible vehicles, and it compared them from perspective of financial cost and environmental impact, basically. That was a nice project as well. So this is the type of projects that you see students working on. We do have a robotics club at a national university. There are about 10 students that are member of this robotics club. We use Arduino board. We use a Raspberry Pi board. They basically use the lights, the motors, the sensors, and switches, connect them together, and that's the hardware part. Again, connecting all of those, wire them up, and then actually write code, write C++ code or Python code for Raspberry Pi to make the design work. So this is actually this is where students can really practice what they're learning in the class in this robotics club, basically. So it's a combination of hardware and software type of a educational environment, so they can focus on both. So as I said, we have 10 students here, and they get together on their own. They don't need me. They get together. They go to the building and work on their designs. A couple of designs that they have done so far. One is obstacle avoiding vehicle. I should say obstacle avoiding rover rather than vehicle. It's a toy type of a thing, as well as drones. They have been able to build drones as well. What else? And finally, some highlights of our program. As I mentioned, we are the program is ABET accredited, both for online and on-site. And in fact, it's one of the very few. In fact, last year, I think we were the only ABET accredited program online in computer science. We have a comprehensive coverage of computer science topics, and by that I mean the 400 level. Students are exposed to operating systems, networking, databases, programming languages, web app development. These are all electives. Computer security, all of them are in the program. They're not electives. The program focuses on software engineering and object-oriented design. So that is one thing that we would like our students to, we would make sure that our students are able to do. Again, that is software development using object-oriented approach. In fact, we in our capstone project and software engineering courses, we promote the agile software development methodology, the Scrum methodology, basically, which is used in the industry a lot. You have opportunity to work with faculty on in computer vision, artificial intelligence, data sciences, algorithm design, and I'm sure that if I start thinking, I can find other topics in there as well. Especially for those students who are interested in software, computing, and hardware engineering, they can actually work with our engineering faculty as well. There's opportunity to be a member of robotics club, actually serve as an officer if they like to serve as an officer. And then also we have student annual scholarship conference at National University, and we have had, for example, our students in robotics club go and make presentation in that conference, and some of our students in capstone project actually presented in the scholarship conference as well, which is a great experience for students. You know, you go in there and faculty will be presenting in front of faculty, and I think it's a great experience to go through that. And again, as much as we can, we use interactive digital textbooks as they become available, and we approve it and look at it, and we believe, yes, this is something that we want to use in our textbook, in our courses, we bring it in. And I think students have been happy with those as well. And this last item, I'm not sure whether it is of any interest to students, but this shows how often our program is offered, basically. Again, the program is pretty much consists of 26 courses, 26 courses, and we call them a string. So this is a program string that's offered. The start of it is Calculus 1, CSC 208, and it is every August this course is offered. A string starts. This is an on-site string in Kearny Mesa, San Diego. And then in November again, another string is offered. These two strings, both of them on site, will kind of merge together. All the courses that are highlighted in yellow, basically the two courses are combined, the two strings are combined. The students from both sections are in the same class, basically. And then we have online courses. Our online courses strings starts in January. That's the first one. And then consecutively every month courses are offered. And then another string is offered in April of every year. And once again, these two strings merge together in some courses highlighted by yellow in here. And students that we have, on-site students, oftentimes it is between I would say 18 to 22 for on-site. It could range from even 15 to 22, 20, 23. On-site, these are on-site, by the way. Let me correct myself. So on-site classes, average class size of 18. Yes, that is fine. Online, it'll be a bit more. So online, you would see somewhere between 25 to 30 students in online classes. This is the average number of students that we have. So with that said, I am done with my presentation and I am ready for any questions that you may have.
Thank you so much for such a thorough and in-depth presentation of the CS program. I just wondered, you had mentioned that there are two strings, the January and April. So I'm wondering if a community college students wanted to start maybe, let's just say February or March, is that possible? And he could just maybe take an elective, or how would that work?
It
they
would
have
be,
to wait.
They have to wait. Probably they have to wait because again, but when you say wait, you said February or March, but the next spring, the next string starts in April. Okay. So it's just 1 month.
Right.
And we do have, as far as I know, we do have preparation classes in mathematics, I believe. And in fact, let me add something because I just remembered one thing. I do say that CSC 208, that is computer science CSC 208. There is also math 215, which is college algebra. That's prerequisite to 208. And that is offered just before 208, perhaps even in March or February. Also, there are physics classes that students can take. So to answer your question, students need to actually start taking classes before these start dates because the curriculum really requires the students to take college algebra, which is math 215, as well as basic physics, physics 104, and physics lab, which is, I believe, 104L, something like that, which I'm not quite sure. Once they go through those 2-3 classes, then they enter CSC 208.
I see. So basically that time that they're waiting, maybe they can take some prerequisite courses is what you're saying?
Correct. So I'm focusing only on courses with CSC prefix.
Okay.
But NU, the whole graduation requirement requires some, again, general education classes as well. And they can, as you said, they can actually start with those and then they need to target these dates for computer science. They know that computer science dates are August, November, January, and April. Now they can start taking the prerequisite, line up the prerequisites so that they are ready to sit in those starting classes in computer science.
Okay, great. That makes sense. And then I also noticed that National offers a master's in computer science as well. Is there any type of a transition program at all if they were to?
As far as I know, yes. Students, if you recall, undergraduate computer science requires 2 electives. And those undergraduate students who plan to enter into our master program, they can actually take 2 master level courses in place of their undergraduate electives. And those 2 master level courses can count for their undergraduate course as well as their graduate courses. So it is, again, it's double counting type of a thing. So the 2 courses are used for undergraduate program, wonderful, but at the same time, they've taken the first 2 courses in the graduate program as well. Yes, there are those transition programs.
Okay, great. And then I know when I meet with a lot of students, I always ask, what makes your program so unique? Why don't I get my CS degree at San Diego State, for example, instead? How would you answer something like that?
Something like that, well, first of all, I think the type of students that we would be interested in our program, they are adult students mostly. I don't think that they are the type that they after the lecture they immediately go to the library and start reading. They're busy with their lives. So we try to kind of we keep that in mind when we lecture, right? That the lecture, we try to make sure that they understand the content in the lecture as much as possible. Because I myself, when I lecture, I know that student will not have time to run to the library and start reading the content in there. So I make sure that they get it. It is more focused, I believe. So we know what are the outcomes. We just get to those. There are certain again, I've even seen certain textbooks that they, in order to describe a certain, let's say, concept, they take like 10 pages, and after 10 pages they circle around, and eventually you don't know what the concept was. Here I think we are much more targeted. That's what I would say. So
I was surprised to find out we had such a large pool of full-time faculty, which I think is great. What do you think that they bring to the table? Like usually, experience. Have many of your instructors been in the field?
Absolutely, we have the full-time faculty. Actually, they've been in the field of academics for many years, most of them. So they are very experienced teachers. And so that's our full-time faculty, basically. So any kind of research students would like to do, they want to engage with one of the full-time faculty that we have in terms of researching. And then we have adjuncts. We use adjuncts, and they are working in the industry, and they are kind of engaged in recent topics in computing, basically, and they bring that relevance to our classes, basically.
That's great. Last question. So since COVID, could you tell me if you've noticed any trends in the computer science industry, whether it be job opportunities or anything of what you project seeing happening in the next 6 to 12 months?
In the industry, one thing I've noticed, my wife actually is a software engineer. She works from home now. And she says actually more is done at home by herself and her teams. So it's interesting that the fact that they are working remotely, more progress is being done. At least that's, and I believe others also agree. Although if I ask her, they say I prefer to go to the company and work at company in the building. But this is one thing that I've noticed in terms of trends. What's coming? I wouldn't know, to be very honest with you. I wouldn't predict anything. What I've noticed is that students are split. Some of them, right now I teach a class that was supposed to be on site, but it's being offered online. And it's one of those theoretical technical classes in computer science. And it seems like, again, half and half of students would like to be on site because they feel like they're more engaged with the faculty member. And if they have questions, they can immediately just point to problems, point to things, and the faculty is there to guide them. And they believe the online environment, it's not as flexible as that. But there are others who do perfectly online. And our program, actually, I personally believe it's the transition didn't impact it at all. We had everything online, ready, in perfect form, actually. Exactly. So that's it. Did not really impact us much.
Yeah, it was complete 100% online pre-COVID. So I think that's great. Thank you so much. I really appreciate it. Have a great day.
You too. All right, great. Thanks.